everybody, CBQ here with Greenzie, back with another edition of How It Works, where we explain how our product works, diving in deeper detail to help you understand how to make the most out of autonomous mowing. Now today we'll be talking about sensor locations on a mower and how they enable autonomous mowing. The reason it's important is knowing exactly where the mower's cutting decks are, the wheels, the cameras, the sensors, antennas, and all the sensors that make it autonomous all contribute to making it an accurate mow pattern, safe obstacle detection, and obstacle avoidance. Now on a robotic mower like this mean green Vanquish that we're upfitting with autonomous mowing, we first map out temporary locations as we're prototyping the locations of these sensors so that we can then extrapolate and use known locations before we get the final placement when we go to production on the manufacturing line. For example, take a look at this IMU. Now this is a pretty critical sensor where placement is very crucial because it measures movement and acceleration. So can you imagine what would happen if that IMU was placed at the very end of the mower and turned? When the mower turns, it moves a lot further than if it were at the center line and turning not very much. Now that's where the concept of a fully accurate sensor model comes in. Now luckily, we don't have to reinvent the wheel here, as the robotic operating system has a definition called a Universal Robot Description Format, or a URDF. Now that's an XML file that describes in 3D coordinate space where all the components of a robot exist. Now for ground robots and differential drive like these zero-turn mowers, the base center line between the wheels is considered the base point from which we connect all of the sensors. Now this file is handcrafted at first, and then we measure and calibrate using software tools to get it as accurate as possible. With a good URDF, we can actually increase the cutting decks, wheel separation, we can even move sensors and still get very accurate transforms, which is the key to making an accurate model of the mower that performs well in the real world. Now another benefit of defining all these sensor locations even temporarily and then finalizing them during movement is that we can now simulate the mower in software. This is how our software team can drive the mower around in a simulated world and test many aspects of the software before we even get it into the field. Now these files, these sensor location files or URDFs, are all versioned and they're stored in our software. So when our software loads, it knows on which mower, which serials, which IDs, and which type of mower for all of the different equipment that we work with. All right, so that wraps it up for this episode about sensor locations. As always, let us know in the comments what you'd like to see, anything you'd like us to explain about how our product works. Thanks for tuning in.